Okay. Good morning, everyone. My name is Vanderdonckt from University Catholic de Louvain, Belgium, in Brussels. And the main theme of this workshop is about involving the human in the loop, right? So I'd like to share with you some experience we gained in addressing this topic through adaptation of user interface. Of course, everybody of us, we have already tried to adapt the user interface of our system to our own needs, preferences, habits, or preferences. But it's always a mess. Why? So I'd like to share that with you so you can see more about here. All of these slides, you can download them for free from SlideShare. So if you go to slideshare.net, you can download these slides at any time, including the videos and other materials. And if you want, you can also send me an invitation through LinkedIn so that I will be in touch with you. It's always appreciated. Anyway, so first of all, before talking about what is an adaptive user interface, I'd like to define what an intelligent or so-called intelligent user interface is. So a very old definition is any type of knowledge about the domain, about the task, about the user, about the environment could be incorporated in the user interface so as to exploit it or adapt it. But that's a very old one. A more recent one is an intelligent user interface is supposed to improve the efficiency, the effectiveness, or the naturalness of how we interact with computers. For instance, if I'm using here PowerPoint, I'd like to be more efficient, or I'd like to control the presentation in a better way, or in a more natural way. So how can I do that? Of course, there are several ways to do that. Today, we may see an intelligent user interface as an interface that encapsulates some artificial intelligence or machine learning technique in order to support this adaptation. So throughout this presentation, I will show you a series of examples. Some of them were negative, because we failed. Some of them are positive, because we succeeded, and then we went a step further. So I will be very illustrative and not very much into details of the technique. So an intelligent, of course, intelligence, it depends on our definition. Some people say that intelligence should mimic what we are doing so that in the end the user interface would behave like you really would like to do so, but not all the time. Some of us say it should focus on the knowledge, so the system should know you, what you are doing, and predict what you would like to do next. Like what's your next action, what the next word you would like to type, what the next email that you want to write, or what the next SMS that you want to send. That's another way. In terms of discipline, of course, the user interface is always relevant to the area of human-computer interaction. That's the main discipline. But it has a lot to do with software engineering. This is my part. It's how we can develop such application in a way that the system will monitor what you are doing and improve or at least adapt to what you are doing, and hopefully it will be better, but not all the time. Of course, for this purpose, the intersection between those two areas is so-called EICS. EICS is an ACM community which has a number of conference on that, so you may want to check on the web if you like. Then, of course, since we are touching human aspects, human factors, all the social sciences like psychology, cognitive psychology are always very important, although I'm not a psychologist, I'm sorry. And finally, of course, last but not least, we have to deal with artificial intelligence. So intelligent user interface is the intersection between HCI and artificial intelligence. And again, IUI is also an ACM community with a number of conferences, so there is a very precise definition. But now, adaptive user interface is just the middle. So we have to be very much aware of who the user is, we have to know some software engineering techniques, and we have to apply the right artificial intelligence or machine learning algorithm. So I will show you some examples of that. So an intelligent user interface is not like a classical interface where you have the interface of top, the semantic core with the database and all the stuff below, and the control ensuring the interaction between those two. So that's a traditional architecture. An intelligent user interface is not like that, And it's not like also an intelligent system where the intelligence is in the semantic world. So conversely, the intelligence is in the interface itself. So there is no interaction with the database, there is no interaction with the semantic world or the functions. Everything is in the user interface. So the results of that interface become huge. So adaptation first, if I'm telling already, I hope that will be also very realistic on that. If I take a definition from biology, adaptation, of course, any species want to adapt to the environment, the conditions, whatever. But here in the context of adaptive user interface, it means that the system should adapt to what is called the context of use. The context is always three things. For instance, there is here a context of use. So the first dimension is the user. For instance, I am the user using PowerPoint on the laptop in this auditorium. So I'm the user, first dimension. So I want to have some reference, some characteristics, some way to interact that need to be incorporated in the system. I can have also some constraints imposed by the platform. I am using a laptop here, but I could use another device. And of course, the environment, the light, the conditions, everything can influence, in principle, the adaptation. Of course, it's impossible to take them all together. It's just too much. But there are many aspects that can be taken into account. I will show you only a few of them. But the main question is, who is controlling the adaptation? We are all human, and in principle, of course, we have different capabilities, but when we have to adapt to another context, let's say I have to move to another country, another language, another culture, it requires adaptation, of course. And it always takes time. In psychology, this is referred to as a cognitive destabilization. So if I have to move, for some time I'm confused, I'm trying to find out milestones, clues, or whatever. But after a while, I become adaptive. The interface is exactly the same. So to control this process, we can say that either it is the system, or the user, or a combination of them. So a first example I'd like to show you, not so usual adaptation, depending on a very unique device called the triple screen. So here is a device that you can plug on your laptop, you can extend it, you can then unfold two lateral screens, on the left or on the right, you. You can even deploy until the end, and when it is fully deployed, you can rotate your screen in any direction in order to share your presentation with colleagues. So you can rotate them in any direction, and even on the back. So for instance, if I'm here, I can put this screen here, you see my screen, and I see my screen, which can be different. So here is a commercial of this Belgian company we are working with to show you how it works. Of course, it's commercial, so. But you will see how it works. You will see that it's a device that you can just plug in, fold, unfold, rotate, or even detach. And in this case, any detachable screen can serve as an extra screen for your smartphone, your tablet, or even your game control device. You see, you can rotate. You see here, you can also detach. So this is a triangle setup that I will explain in a minute. Okay, so here the adaptation is that you have seen many configurations of those screens, right? We can touch, fold, unfold. So we built a system that, depending on the configuration you're using with the device, your user interface in the browser will separate these different things depending on who is attending. For instance, if I am here, let's say here, I have two persons here who are interested in some aspect of my presentation, while this other person is interested in some other aspect. I can divide it into three parts. I see, of course, all the contents, but then the contents that is relevant for those people here on the right will be dispatched on the right screen, while the others will be adapted on the left. So this is something like this. If I'm, for instance, on the bottom, you can see if I'm extending the browser window, then I have, of course, the very awkward problem of the bezel, right? But with our system, it always cuts in some interesting parts, and I can see this is the part for presenter 1, presenter 2, or attendee number 1, number 2. So this is a little bit unusual. So first, there are two different ways of adapting things. First, adaptability with the suffix able. So I'm able myself to adapt the interface if I want to do so. For instance, here in PowerPoint, I can customize my ribbons with new icons, group, etc. So I can create another one and then move icons from the left to right and create a new group. So here I am in control, I am user, so it's called adaptability. Now, adaptability leads to another term, which is customization. So if the system is a little bit more intelligent, I can customize more than just picking a few things. So here is a very old project where you can rephrase the entire interface of a simple application. Here it's just a calculator. So you will see that first the calculator is running. So it's a simple calculator. You can see, of course, traditional functions like economic, etc. But you say that, of course, this interface is always the same for everyone. I want to have a specific one because I know that I'm using only a few functions, not all of them. So what I can do is, in this parameter window, I can select or unselect all the functions that I want to keep. And then I say, okay, I will keep this one, or for instance here, I don't need the tangent, I don't need those functions, etc. So this is reflected from the project. It's a C++ requirement. And then the system recompiles. And in the end, after recompilation, of course, you need a few seconds, you will get a new version of the application with all the codes, but only the function that you needed. So here is the browser. Now, as you can see, this is a new interface with the same functions, but only tailored to my own needs with the interface already adapted in the layer. So this is called adaptability. The nice thing is here is that I can control my process, so my satisfaction is in principle better, but it takes time. On the other hand, if the adaptation is controlled not by myself, but by the system, it's called adaptivity, which is a little bit tricky because, of course, maybe you have already seen a system that changes automatically, and you don't know why, or when, or what happened, so it's always a cognitive disruption, and we are puzzled. So here is an example of such an adaptive user interface in a control task. So here on the left, the people had to control a file for some secrets, and this is the standard user interface they received in the beginning. So everyone at the connection, they started using the system, and the system adapted the user interface automatically to the process that they were following. So here is one user who used all the functions one after one. So file number 1, number 2, number 3, etc. So the system readapted, reshuffled all the widgets accordingly. The nice thing is that the acceptance is better, the error rate is decreased, and the cognitive load is so-so. But the key thing here, especially with respect to the human in the loop, is that here the user does not control anything. That's the drawback. Another way to adapt is so-called personalization, which is different from recommendation. And we are all familiar with Amazon recommendations. Amazon recommendations, it means that the system adapts my interface and my contents, not according to only what I'm doing, but also according to what others did, or other preferences. So personalization is the same, but according to what I need, or what I did, what's my history. So here is an example of an electronic website that we developed where, as you can see, the first item has been a little bit highlighted because the system captures some interaction history and deduces from it that maybe this device would be more interesting for me. So here, it shows that by eye tracking, of course, more fixation points were on that device. So playfulness was increased, and my customer experience was also better. But surprisingly, some people even didn't notice that there were some adaptations. So this is not very important. The most important is that the customer experience was better. So there are drawbacks and advantages for each solution. For instance, with respect to the system point of view, the adaptable, okay, I don't need to go too much. And of course, the processing is not too high in consequence. However, in the adaptive part, the code that I need to develop for that would be high to very high, and even have an impact on the interaction to slow down the system. For the end user point of view, of course, adaptable, it's low because I cannot modify many things. For instance, if I want to customize the ribbon, this is one thing, but adaptation is very easy. On the other hand, in the other example, the adaptation for that can be very expensive, but it takes time for you to control. And in the end, the performance could be very good, but the consumer or the results that you need to consume for that purpose would be very demanding. So here, it's very good for performance or efficiency, but not very good for control. Adaptability, it's zero. So the consequence of that is, since neither adaptable nor adaptive is good, so we have to find out something between, so-called mixed initiative. So maybe you have already heard about that. It's a principle that has been introduced by Eric Horvitz from Microsoft some years ago. So mixed initiative is that instead of having the user or the system controlling the adaptation, it's a collaboration between the two. But now the problem is that how we can have a good mixed initiative. How can we ensure that end user will have the control at the right time and not always? So here is an example from Eric Horvitz. He was writing an email, and in this email, the system detects that he wants to plan or to see during a meeting. So automatically it opens Outlook. Automatically it searches the next free slot in common with the other person and propose this slot for a meeting automatically. So this is something that is almost done now in Outlook, but not always. So in order to characterize the different levels of mixed initiative, here is a range starting from, on the top, adaptability, where everything is in the hands of end user, until adaptivity, where everything is decided by the system. And in the middle, you have several options for mixed initiative. I will show a few examples, but in the end, we can come back on that. The nice thing is that, of course, the more control I have, the less adaptation automation I have. If I have zero control, I have a lot of automation possible, but that doesn't go back. On the other hand, if I'm here on the top, I have more control, but I have less automation. So I need, as an end user, I need to input more information and then to take time to control my adaptation. So I will also classify the adaptation example that I will show you in a minute according to the programming language. So a very old example here is a toolkit for adapting user interface for disabled people. For instance, if I have cognitive impairment or visual impairment, so the system says, okay, you need to adapt the menu and the menu consists of 15 items, and my user is partially blind, he's using a braille system, so that activity said, okay, now the menu should have one single level, no pull-down menus, no hierarchy, and there should be on screen, so that the screen reader will be able to read one item at a time from the menu, and then this returns to the system. So this is level 3, because, of course, there is some possibility. Here the system proposed a few adaptations, and the user picked one of them, and the system executes. So this initiative is there, but it's very limited. Another example here is a little bit more sophisticated from EUIS. So the system starts from a form, and after a while, after the end user has used this form extensively, say 20, 30, 50 times, the system automatically deactivates some parts, emphasizes some other parts, and transfers some other portion of the widget in another. So in the end, this is one example. So as you can see, this is probably better for efficiency, but the drawback is always confusing, and it's just why? Or suddenly my interface is changed. Why? I don't know, I have no idea why. So this is always the end user description problem, and we are only one of that. So here, the system does that automatically, so there is zero control. And for instance, this is the code, you can, as an example for showing that. So this is just one function, right? And there are hundreds of functions like that, so complexity. Second example is a system for selecting the right widget, depending on my task and depending on the domain. So here is a system that uses a decision tree to select the most usable widget for every piece of information. So this is nice, but again, this is complex. So here, once this information is in the system, then it displays you a decision tree. Say, okay, the system automatically selects this widget for that information because of all of these parameters. So you can see where it is. So for instance, here is the density is not so high, so it should select a radio button with a group box. So the system knows that and automatically generates an interface for you according to that. So here, the selection can be manual. I can pick and just say, I want this one. It could be automated. I don't want to intervene. Or I can see the decision tree say, I'd like to have this one, but maybe I'll change to another one, so that in the end, my interface will be a little bit more controlled. And in the end, if I really want to do so, I can even access the code in a pseudo-natural language, and I can rewrite, of course, if I'm an expert, but a very few users do this. And the system can, of course, update the rules. In the end, there are many rules, hundreds of them. So here is just a matrix to show them. And the drawback of that is that the more rules we incorporate in the system, the better it is. But the more complex it becomes to maintain. Would imagine that the engineer who is responsible for maintaining 300 adaptation rules, after a while, this person becomes crazy. It's impossible from anyone's point of view. So this is the drawback, is that after a while, the expressivity, we have a lot of parameters, a lot of adaptation rules, okay, in principle it improves, but on the other hand, we have a plateau, is that we improve, but not so much. And the system becomes too complex to manage. So this is not a good solution. Here I'd like to show you another example, combining different types of adaptation. So not just the adaptation of the user, but also adaptation to the context, and also what I'm doing. So it's a combination of a weather forecast application and a road planner system. So let's imagine that I'm a traveler. I want to travel by bicycle, by foot, by horse, etc. And I'd like to have weather forecast. So first I can specify what I'm interested in, nature, trade shows, whatever. Or I want also to know what are the specific weather forecasts. For instance, if I'm in bicycle, I would like to bicycle when it's not raining. So with a system of proxy, so my interface is here. It sends through a proxy a request to the data. the data are then retrieved from web service and then reshuffled by the proxy depending on who I am and depending on my query. So here are a few examples. Again, there are a lot of rules. I'm not sure that, and just to give you an example. So here, this is for a smartphone, this is for a tablet, this is for a desktop. And you can change depending on light conditions, depending on whether I'm blind or depending on whether I have cognitive impairment. This is only for walking. If I'm not just walking, I'm not interested in weather forecast. If it is during the night, or if it is for an end user who has some daltonism, contrast between colors. So here, I'm not that, so I'm going to check. But in principle, the contrast would be enough. So this is another example. The drawback of that approach, although this application has been deployed on iOS, on Android, and on the web server, so it was fine. But after a while, we realized that this is not always good for everyone. Is that, of course, we have good rules here. And we say that, for instance, this rule on mobile is better than that one. So this is a second order. But for some other users, we have to reverse the order of the rules. So we have to introduce so-called meta rules and even meta rules, which is crazy. Again. So here, another example that is a little bit more sophisticated, where we would like to adapt the interface depending on the crowd. For sourcing, for funding. So here, why not taking advantage of the crowd in order to adapt my user interface? So here it's a simple form, whatever the form is. So the form is dispatched on the web, and at any time I can change. Okay, here my birth date. I'd like to adapt my interface with another widget that is supposed to be better. Okay, so if I'm starting in the adaptation mode, the system prompts me with other solutions, and I can pick any of them at runtime, and the system adapts for that. So for that, behind, there is a big scoring function, depending on many parameters. For instance, depending on what the other user did, depending on what the designer said. So the designer said, okay, this is the best widget for that condition, so it's equal to the system. Or even the developer yes said, well, this widget might be very interesting, but it's very complex to develop, or it is very slow. So all of these parameters are taken into account in the scoring function. And by using a KNN algorithm, let's do this for a minute, the system can adapt. So what we observe, interesting thing, is that after a while, people changed the interface, but after a while, they no longer change, they converge. They stop changing. So here is an example. After a while, they switch from text field to text area, and after a while, they don't change anymore. So here, as you can see here, also, so every bar denotes a change in the application. So surprisingly, what was interesting is that we left the possibility to change to adapt, but after a while, they no longer want to adapt because apparently they are happy, or they no longer want to spend time for adaptation, they just keep it back. Okay. A bit complex. Now, more recently, especially when we have devices with different screen resolutions, and we have sometimes tiny screens until huge wall screens. So the drawback of that is we have to adapt the screen resolution, dimensions, number of colors of every screen. So here is an example of a system that was developed recently using a constraint satisfaction problem in order to adapt the interface depending on the screen size. So here is an example. This is in Java, but there is also a JavaScript version. You can check if you like on the link below. So you can see here, while I'm resizing the window, the system knows what is the current dimensions of the windows and reshuffles all the widgets and substitutes the widgets accordingly. So for instance, if I have a big radio button, after a while it will be reduced to a drop-down. So this is the Java version, or you can use also the Java. If you go to this source, you will see you go to the Okay. So the nice thing with that is, although this is automatic, you can also control it. Here on the right, you can say what is your preferred widget depending on the condition. So for everyone, here each step denotes a widget, and you can click on them and say, okay, in this case, I prefer this layout, or I prefer this interface, and the system keeps that for you for next usage. More sophisticated example from here, from University of Luxembourg, which is so-called auto-completion. So this is a system where the system adapts the user interface depending on what has been already done, and predicts what will be the new user interface widgets depending on the interaction history. So this is a very sophisticated example with a neural network and also a KNN. And in the end, after that, the system shows that the adaptation is better. For instance, as you can see here, people approve it, or people disapprove because they are not happy. And in the end, the approval is always better. And they show that depending on the alignment, whether it is left, top, right, bottom, or many combinations, systems adapt to that according to a neural network, which is a very sophisticated example. Now, the last but not least example that I would like to show you is how we can adapt the user interface in the very last level. And you can see adaptation level is 6. So no code, no language, no programming language, no markup language, only natural language. So here is the system that was developed in 2020, so some time ago, before ChatGPT, but using the same technique, which is a transformer based. So the goal here is the system is left in the hand of the user, and the user will interact with the system in order to create a web page that is adapted to her needs.
How you can generate a web page and all of its code by using your natural language. In the left column, you can ask Teleport HQ to create some page sections. In the second column, you can preview the sections automatically generated by our model. You can then select the one you prefer or start a new generation. Now, let's try to be more specific. Let's ask for a section with 3 paragraphs and 3 images.
So here the system retrieves some adaptive layouts.
This one looks good. Let's select it. Now, let's ask for a footer with 1 image and 6 links. I like this one. Let's add it to our page. Finally, I'm going to ask for a menu with 1 image and 4 links. In the third column, I can now reorder all my sections as I want. While doing that, I just realized that I need a hero section as well. Let's ask for one.
So here we are typing, but we can also have with speech-to-text recognition.
There we go. Let me adjust its position. For now, my web page structure is ready as a wireframe, in low fidelity, but I can switch to high fidelity at any time. In this example, we applied some design style elements from Adobe.com. In this other example, we applied some design style elements from Microsoft.com, but the engine can be adapted to use your company design system. While I remain focused on building my web page, the code is generated in real time, in React, Angular, or Vue. The current demo displays 3 languages, but our code generators already support 10 languages out of the box. I hope you enjoyed this short technology preview of our GPT model for user interfaces code generation, which opens the way towards conversational application building.
So as you can see here, there is 0 code. No, I'd say no jargon, no special vocabulary. I just say I want to have a web page with a footer, with images, with paragraph, and the system retrieves some layouts that have been retrieved from the web. And the system has been trained with about 330,000 websites. Good websites, and not bad ones. So in my example, what I wanted to show you is that, of course, if we automate things, the system can do a lot of things, but the control is very low. The more automation I have, the less control I have. The more control I want in the application, the less automation I can do. So it's a drawback. If I want to have a user who does not want to spend time in adaptation, I say, okay, I'm happy with what the system can do. Whether it is good or bad, that's another question. Not always better. But although it's always for the ultimate sake of the user. On the other hand, if the user involves a lot of effort, the automation is low, but the adaptation process will be a little better. So in the end, in order to really support the theme of this workshop, which is about human in the loop, I'd like to share with you a life cycle that we have used for years, that we are using right now in a real-time project led by Professor Luis Leiva from the team, which is this one. So it says that for adaptation, it goes through a cycle. Let me explain you that, and this is my last message. So first, what is the goal for adaptation? So let's say I'm a tall guy, I want to have, or I'm suffering from myopia, so I want to adapt my interface depending on my sight vision. That's my goal, so I can specify that. So here the system says, okay, it is the user, the system, or a combination of the goals. The system can also detect maybe you're struggling with part of the interface and then initiate some adaptation. That's another thing. So after specifying my goal, who takes the initiative for adapting? Is it the system that will say, hey, you are doing many errors, would you like me to help? Or say, no, this interface is just too small for me, I want to increase the size of the forms or more, so this is my initiative. Or it could be a combination. Next step, so this is first step, initiative. After that, the second step is specification. What should I do in order to adapt my interface? Should I change the font? Should I increase the size of the widget? Should I leave some part of it? That's another thing. And in the end, the system should apply it. The problem is that once the adaptation has been processed, there are very, very few systems that shows transition. You always have a state before adaptation and a state after adaptation. And nothing between. So this is very good for end users. They say, something has changed, and they don't know why, they don't know when. So they need interpret. So in order to have a smooth transition between before and after adaptation, we need some transitions. We did that with animated transition. The nice thing is that we thought that it would be very helpful. It was. But in the end, the end users say, okay, at the beginning, they really want to show the continuation of adaptation. But after a while, they say, oh, I no longer need it because I trust the system, I've seen it several times, so I no longer want to see it. So we have a sophisticated system that in the end is no longer used because people say, okay, I trust the adaptation, so no need. However, they really need the next step, which is interpretation. Is that, how you reduce the size of this dialog box, or this part is being removed, why? You never use it. Okay, so I understand. I never use it. It is now an option. Right? And the evaluation. This is the last step. Evaluation. Is it better for you or not? So many studies have tried to show what are the benefits and the drawbacks of adaptation. And it's not always very straightforward. It depends on many parameters. For instance, one of the studies showed that some adaptations are very good for most people, but it depends on the psychological traits of the person. For instance, I prefer to type, I'm fast to type, so the system can detect that. But if this adaptation goes to another person who prefers to select things instead of typing, it will take time, and the user could be a little bit frustrated because the adaptation does not work for that person. So in this life cycle, we try now to have something that will help the user to control the initiative when I want to adapt, and not let the system say, okay, I will do things and I don't know why. I want to say exactly what the system should do for me. I want to reduce this, I want to adapt this menu, or I want to shrink that interface, or I want, as you have seen, I want to resize my window. So I specify myself, and the system applies it. In the end, I can see what has been changed, and the system should tell me how I will benefit. For instance, I will be faster, right? Or I will be more natural because the flow is more in the way that I like it. Or the system will improve my overall user experience, not necessarily for efficiency. Speed is not always the key, but sometimes just the satisfaction is enough. So this is the last thing. So this is what we are applying right now in the European project Keynote that is led by Professor from University of Luxembourg. So we have, if you're more interested, we have something for every step now. Thank you very much for your attention and ready for questions now.
Maybe that's also the way you do what's happening because of food. The region specifically. What's the learning how you are actually changing or adapting and foods that you completely black box machine learning language. Knowledge base and some rules of the most.
The question is, and you have seen that the GPT-based adaptation here for our website. The big advantage is that it was trained, as I told you, on a large amount of websites that were supposed to be with a good design. It's not always the case, most of the time. We checked all of them, so the system parsed the code from that and installed in the database. So the advantage of that is that it takes advantage of the many good designs that are already existing, and that I don't need to reinvent the wheel, especially for a user who is not, let's say, a user interface designer or a user interface experience expert. So that's nice. However, the system does not know everything. So we have seen in our experience that some people ask for a very strange web page, and the system said, I have no example, or I cannot quite. The system always generates something. Sometimes it generates crazy things. Why? Because it has been trained on some crazy things as well. So the system only reflects what has been trained for. So usually I like to say, instead of reasoning, and what you see is what you get, here is what you get is only what the system was trained for. So if it's outside, you don't have it. So some people said, okay, for instance, I want to have a carousel of selecting pictures. Because this person likes it in that field. We have very few examples of carousel website because the JavaScript for that is very specific. So the system was not very well trained for carousel. And the system, and you ask, I want to have a carousel, and no carousel. So, and then the system was not able to generate a carousel, meaning a real web page. The end user was really disappointed. So this is a big drawback. As soon as it is you have seen when the person is trying to create a request, with that by natural language, as soon as it matches what has been trained for, it works. As soon as it is a little bit outside, finished. That.
It think that it could be like what layers rules that you could carousel, you could just give it the code to the carousel so you actually going to the initiation goal. You think that something like that would work?
Of course, when we have good example of carousel, we can incorporate and retrain the system, but this is not done in real time.
Yeah.
It's in our implementation now. I told this some years ago already, and it was before GPT, but GPT was with GPT-2 at that time, full time now, and we have almost 55. So the drawback of that is that as soon as it goes outside the scope, it doesn't work. But of course, you can retrain. So we say, okay, now we have these good examples, so you can ignore them and retrain the system. But this is not in real time. That's the problem.
Thanks.
Anyway, I will be around, so if you have any question or if you like to chat. So again, all my slides are on SlideShare, so you can download them for free using the video or the links. When you click in the presentation the links, you can see the papers and the videos. You have a question?
Thank you very much for the thank you very much for the interesting presentation. So I have a question: is adaptability of a system or adaptability? And so there's this threshold, yeah, this continuum, and in the middle, at one point, you say gives up this the choice of the users, and they continue with the what the system permits. So if we don't let the user choose or customize, would they adapt from the beginning? Would they prefer to work with what they were given rather than customize? So how this will affect the user? Because most of the current interfaces are not letting the user to choose the interface that they want. So how this would affect to the adaptability of the system?
So your question is about how we can provide such a system so as to make the interface adaptable instead of adapting?
Yeah.
Okay. So right now, if an application has not been instrumented in the code with such things, it's impossible to make it adaptable. However, again, here the mix initiative, right, which is a mix between adaptability and activity, is something more doable than pure adaptability. Because adaptability, well, we can give many things in the end user, but we don't know what end user will do. And sometimes the end user does some adaptation that are even worse than the initial interface, because the end user just tried. So instead, here in the last version, where the system proposed several adaptations, so first adaptation number 1, number 2, number 3, which one do you prefer? The system already has a weight behind. So this is probably the best one, but if the user prefers another one, this is the choice of end user. But at least the decisions are kept in the main domain and not outside.
Okay, and the other question was, so there are many parameters to check. There are many parameters to check. So was there any research going on to narrow down these parameters into fewer, like very fundamental ones? So one example that you provided was that these might be related to personal traits. So something like that. So this is personal traits, like if you take big 5% rate, this is just 5 dimensions, and you can customize the cases based on these 5 dimensions. Was there any other approaches in order to narrow these search scores down?
No. So there have been many works which investigate only a few sets of those parameters, but the problem is that it's not incremental. This investigate this one, the other one that one, the other one that one, so it's a multi-factor phenomenon. So it's impossible to take them all to account, right? And even if we want to narrow down to a few of them, there is no application yet in this format. We know for some types, in this case, of these parameters we know. Of this other set of parameters we know. But combined we don't. That's it.
Thanks everyone for joining us in this session. And
My pleasure.
very
Have a
much.
nice day.
We have a short break. Some meeting outside. And be back here at 8:30. we will have a second tutorial on collaborating AI systems for databases. See.
Hello.
Really nice talk. I really enjoyed it.
Thanks.
So, my work in my PhD is quite centered about actually user
Yeah.
adaptation.
Oh, great.
Adapting interfaces.
Where are you working?
Deep Guy, Germany's Center for Artificial Intelligence, it's right across the border from
Okay,
in
great.
Germany. So we're still in Saarland, but we have multiple locations
Yes,
in
indeed.
Germany. Yeah, so, but I'm from the Saarland University.
Okay, yes, very well done.
Yeah. So yeah, I work a lot also with that in actually today with the talks for the papers. We have this position paper. It's not actually like a full paper. We just highlight what we did before. Where we talk what we wanted to do is relating to this interaction, I would say, hybrid way of doing adaptation, where we mix. Yeah, exactly.
To some extent.
To some extent, but instead of looking at from the user and the system level, we actually, now that I understand the background behind it, because I work mainly in the learning part, we are mostly in the autonomous, very uncontrolled part.
Self-adaptive.
Self-adaptive, but we are mixing the wave rule-based and learning. That's why I asked you this question. It's like this is something that you think would actually make sense, because that's what we are trying to do, is that let's say we have this all of use cases, like you mentioned with the carousel. We have all of this use case and something, but we know that some of the rules are missing, and then we start saying, okay, how can we add this rule? And also it's not a replan, but how can we somehow predict these rules are going to happen? Then
That's right. My belief is that it should be a combination of both.
Yeah.
We have been using rule-based approach for many years, and as we have seen in the last example, we have too many rules, and this time became so complex that it was impossible to manage, and it was very slow to adapt. At some point,